Okay. Suppose you are given a relation R with four attributes A, B, C, D. For each of the following sets of FDs, assume those are the only dependencies that hold for R. Do the following. First one, you have to find out what is the candidate key for R, the relation, and identify the best normal form that R satisfies. Whether it is whether the given relation is in first normal form or second normal form or 3NF or BCNF. If R is not BCNF, then convert it into BCNF relations, right? Here, there are four relations with four FD sets. So R with FD set. Okay, now we'll see first one. So consider the relation R with attributes A, B, C, D and FD set. Okay. So what is the first step? We have to find what candidate key. So find the candidate key. Okay. How to find candidate key? You have to find out attribute closures. Okay. See here. So first take this one. You see here. First we need to find a candidate key. So find the candidate key. Okay. So how to find candidate key? First we have to find out attribute closures, right? First find attribute closure. So A closure. So what it will give? So A will give A. See this FD. A gives then B. Okay. A gives A and B. Next. So what about C? C gives only C. Then from this FD, C gives D. Okay. What about B? B gives only B. D gives only D. Okay. So it is about attribute closures. Now we need to find what candidate key, right? So what is the candidate key? So what is the definition of candidate key? So it will determine all the attributes in a relation, right? Now AC will give. What about A? A gives AB, C gives CD. So it is the candidate key, right? AC is the candidate key. Okay, what is the candidate key? So AC is the candidate key. So candidate key is okay, AC. Now, so what about prime attributes? So prime attributes are key fields, right? That is A, comma C. Okay, what about non-prime attributes? Non-prime attributes. So non-prime attributes are okay, B, comma D. Okay, it means non-key fields, right? So first we have to find out what candidate key. For that we need to find out the attribute closures. Find A closure, B closure, C closure, and D closure. Okay, A closure gives C and B. What about B closure? It will give only B. C closure gives C and D. What about D closure? It gives only D. Now what is the candidate key? AC is the candidate key. Okay. Now what about prime attributes? That is key fields. What about non-prime attributes? B and D, right? Now what is the second question here? See here. So identify the candidate key. Okay, we find. So what is the candidate key? What about that? So identify the best normal form that R satisfies. We have to check whether the given relation is in first normal form or a second normal form or 3NF or BCNF, right? Now see here, there is no nested relations and there is no okay multi-valued attribute, right? So it is in first normal form. Yes. Now we need to check for 2NF. What is the definition of 2NF? It must be in 1NF and there should be no partial dependency. So what is the meaning of partial dependency? Part of the key to non-key. Now we have to check for partial dependencies, right? Now check here. See here from this FD set, see there are two functional dependencies, right? Now A, what is A? A is a part of the key. A is a part of the key. Okay, A is a part of the key. Part of the key to what is B? Non-key. So it is having one partial dependency. Next one, what is the C? C is again part of the key. What is the D? Non-key. So it is having a two partial dependencies, right? So it is not in 2NF. Okay, it is not in second normal form. Okay, so convert this into what? BCNF. See the second question. So what about second question? See here. So first point is you have to find out candidate key. Then you have to identify the best normal form that R satisfies, right? Now it is only in first normal form. So it is not in 2NF, right? So the highest normal form is it is only in 1NF, right? But it is not in 2NF. Okay. Now, what is the next question? We have to convert this into what? BCNF, bisected normal form. Okay. So now convert it into BCNF. So what is the definition of a BCNF? So we know that. So what is BCNF? In BCNF, every determinant must be a candidate key. Now see here. What is the candidate key here? So AC is the candidate key. Okay. Now check the first FD. A determines B. So what is the definition of BCNF? Here the left side it must be the candidate key. A is the candidate key. No, it is not a candidate key. It is a part of the key. Okay, it is violating the rule of BCNF. Okay. Next, see here. C determines D. What is C? Is it a candidate key? No, it is part of the key, right? It is not a candidate key. So again, it is violating the rule of BCNF, right? So now we have to convert this relation into what BCNF, right? Now write all the attributes A, okay, B, then C and D. So where is the violation? C to D. Okay, next one, A to B. Okay, it is violating BCNF rule, right? Now keep CD in separate table. Okay, next keep AB in a separate table. AB in separate table. What about remaining attributes A and C? So keep A in AC and separate table. Okay, now it is converted into what? BCNF, right? Bisected normal form. Now see the first table A to B. Here A is the candidate key, so it is the FD. Okay, here C to D. C is the candidate key. It is the FD. Okay, here it is combinedly candidate key. Now A is foreign key referring to this table. Here C is a foreign key referring to this table. Okay, so it is about BCNF, right? So converting the given relation into BCNF. BCNF means what? Bisected normal form. So what is the definition of bisected? Every determinant must be a candidate key. It means what? The left side must be the, see this FD set, the left side must be candidate key. Okay, if not, we have to convert it into BCNF like this. Okay, so we'll see one more problem. See the second question. Consider the relation R with attributes A, B, C, D and FD set. A determines B, B determines C, C determines D. Again, we have to find out what candidate key, then identify the best normal form that R satisfies. Okay, and if R is not in BCNF, convert it into BCNF. Okay, now see here, see the second one. So consider the relation R with attributes A, B, C, D and FD set A to B and B to C, C to D. Okay, first we need to find what candidate key. So we have to find attribute closures. So what about A? A closure. A closure it will give A. Here from this FD, see here. A gives B. Okay, then from B, B to C, B gives C, C gives D. So what is the candidate key here? A is the candidate key. If I find B closure, what it will give? B gives only B. From this FD, B gives C also. Okay. B gives C, then C gives D. Okay, so that is about B closure. What about C closure? C gives C and C gives D. Okay, C closure, it gives only CD. What about D closure? D will give only D. So finally, what is the candidate key? A is the candidate key, right? Now we have to find out the best normal form or that satisfies, right? Now what is the key here? A. Here key has only one field, right? If the key has only one field, then there is no partial dependency. It means what? There is no part of the key to non-key. Now check here. A determines B. What is A? A is candidate key. Okay, candidate key to B. Now B to C. What is B and C? Non-key to non-key. C is a non-key to non-key. So it is in a second normal form. Now we need to check for whether it is in a 3NF or not. So what is the definition of 3NF? It must be in 2NF and there should be no transitive dependency. What is the transitive dependency? Non-key to non-key. Non-key to non-key. Okay. Now we need to check for 3NF. It means that there should be no transitive dependency. Now check first step D. A determines B. What is A? Candidate key. So A determines B. It is valid. Okay, because A is candidate key. Then B determines C. What is B to C? B is non-key, C is non-key. Here it is having what? Transitive dependency. Next check for C to D. So what is C? Non-key. D is also non-key. It is having transitive dependency. So it is not in 3NF. It is not in 3NF, third normal form. It is in only 2NF, right? The best normal form that R satisfies is 2NF, right? Now we have to check whether it is in BCNF or not. So what is the definition of BCNF? So what is the definition of BCNF? Every determinant must be a candidate key. What is the candidate key? A is the candidate key, right? Now see here, A determines B. A is candidate key, it is valid. Yes, it is satisfying the rule of BCNF. Now check B to C. So B determines C. What is B? Is it candidate key? No. So it is violating BCNF. Again, check C determines D. What is C? C is candidate key. No. So it is not a candidate key, right? So again, it is violating a BCNF, right? So there is a violation. Now we have to convert this relation into what? BCNF, right? Now write all the attributes A, okay, B, C, D also. Okay. So where is the violation? C to D, then B to C. Okay. Now we have to convert this relation into what? BCNF relations. Now keep CD in separate table. Okay. CD in separate table. CD in a separate table. Okay. Now keep BC in separate table. BC in separate table. Okay. BC in a separate table. Now what about other attributes? AB. Keep AB in a separate table. Okay. AB in a separate table. Okay, now it is decomposed into BCNF, right? Now see this table. Here, what is the candidate key? C. FD is C to D. Here, B is the candidate key. FD is B to C. Here, A is the candidate key. FD is A to B. Okay. Now it is decomposed into BCNF. See here. So R is decomposed into one table AB, next BC, then CD. Okay. Now see the third problem. What about third one? Consider the relation R with FD set. Okay, first we need to find what? Candidate keys, right? We have to find out candidate keys. So now here find AB closure. So what is AB closure? AB will give AB. Okay. Find attribute closures, right? So find AB closure. So what is AB closure? So it will give AB. Okay, AB will give AB. And it is giving C also. From BC, we are getting D also. Okay. From CD, we are getting A already there, right? So AB is one candidate key. Now, see here, then BC, find BC also, BC closure also. So what is a BC closure? From this FD, find BC closure. It will give BC. Okay. Then, so BC gives BC. Then it is giving D also. Okay. Then from this FD, CD gives A also. So it is determining all the attributes, right? So what are the candidate keys? A, B, and BC are the candidate keys. Okay. Now, what about prime attributes? Key fields A, B, C. What about non-prime attribute? T. Now we have to check the best normal form that R satisfies. Okay, we have to check whether it is in 1NF or 2NF or 3NF or BCNF, right? Now check this one. First you have to check whether it is in 1NF or not. See here, there is no nested relations and there is no multi-valued attribute, so it is in first normal form. Okay, next we have to check for 2NF. Okay, what about 2NF? It must be in the first normal form and there should be no partial dependency. Okay, we have to check for partial dependencies, right? It means part of the key to non-key. See this FD set. Okay, see the first FD. AB determines C. What is AB? Candidate key. There is no issue. BC determines D. There is no issue. BC is also candidate key. AB and BC are candidate keys. There is no problem. Okay, what is a partial dependency? Part of the key to non-key, right? Now check here. Check this FD. CD determines C. What is a C and D? Is it part of the key? No. CD, it is not a part of the key. Okay. What is A again? Key field. Okay. What about partial dependency? Part of the key to non-key. Part of the key to non-key is there? No. Okay. So it is in 2NF. Now check for 3NF. Third normal form. What is a third normal form? There should be no transitive dependency. It means what? Non-key to non-key. Now AB determines C. It is valid because AB is candidate key. BC determines D. BC is candidate key. D is valid. Now check here. CD determines A. So what is the transitive dependency? Non-key to non-key. CD, is it non-key? No. A, is it non-key? No. So there is no non-key to non-key. So it is in 3NF. The best normal form that R satisfies, that is a 3NF, right? Now we have to check whether it is in BCNF or not. Okay. So what is the definition of BCNF? The left side must be what? Candidate key. See here, see the first FD. AB is candidate key, so it is valid. See this FD also. What is BC? It is also candidate key. It is also valid. See this CD. Is it candidate key? No, it is not a candidate key. It is violating BCNF, right? Now we have to convert this into what? BCNF, right? So now write all the attributes A, okay, B, C, D. Okay, where is the violation? CD combinedly determines what? A. So it is violating BCNF, right? Now keep C, D, A in separate table. That is A, C, D in separate table. Okay. Here FD is a CD determines A. Okay. Here CD is the candidate key. It is the candidate key in this table, right? So what about remaining fields? Keep BCD in a separate table. BCD in a separate table. Okay. Here what is the FD here? BC determines D is the FD. Okay. BC is the candidate key, right? Now it is decomposed into what? BC and F relations. Now see here. So it is decomposed into one table BCNF, second table is ACD or CDA. Okay. Now we'll see one more problem. So consider the relation R ABCD with FD set. Now we have to find out what candidate keys, right? We have to find what candidate keys. Okay. So first find attribute closures. Here find AB closure. What about AB closure? AB closure, it will give So AB closure gives what? AB. So AB closure gives what? AB. From this FD, C also it is giving. So AB determines C. C determines again D. So it is one candidate key. Yes. So AB closure it gives AB. From this FD AB to C it gives C also. From C to D again it is giving D also. It determines all the attributes, right? It is one candidate key. Now take C closure. If I take B closure, it is giving only B. If I take A closure, it gives only A. Now find C closure. C closure gives C. Yes. From this C gives D also. Okay. Then D gives A also. Okay. C closure gives C, then D, then A. Okay. Now if I take B here, if I combine this, okay, then I may get A, B, C, D. So here we will get two candidate keys, that is A, B and B, C. Okay. So what about prime attributes? Key fields A, B, C. What about non-prime attribute? D. Okay. So now we have to check the normal form of this, the best normal form of this relation, right? We have to check for this one. See the FD set. So first we have to check whether it is in 1NF or not. Yes, it is in 1NF. There is no nested relations and there is no multi-valued attribute. Yes, it is in first normal form. Now we have to check for what? 2NF. Okay, what is the definition of 2NF? It must be in 1NF and there should be no partial dependency. What is partial dependency? Part of the key to non-key. Part of the key to non-key. Okay. Now see here. What is the candidate key here? AB and BC. So check first FD. AB determines C. What is AB candidate key? There is no issue. Then C determines D. So what is C here? It is a part of the key to non-key. What is D? D is a non-key. Part of the key to non-key. So it is violating the rule of 2NF, right? So it is having partial dependency. So the highest normal form of this relation is only 1NF. Okay. Now we have to convert this into what? BCNF, right? Now check the BCNF rule, right? See this FD set. According to BCNF, the left side of functional dependency must be what? Candidate key. AB is candidate key. Yes, it is valid. It is in BCNF. See this. C is candidate key. No, it is not a candidate key. So it is again violating. Now check here. D is a candidate key. No, it is not a candidate key. It is violating BCNF rule, right? Now list out all the attributes. A, okay, B, C and D. So where is the violation? C to D. Next one, D to A. So it is violating what? BCNF rules, right? C to D, C to D, then D to A. Now keep AD in separate table. Next, keep CD in separate table. What about remaining attributes? Keep BC in a separate table. Okay. Now see here. Here FD is C determines D. Candidate key is C. Here, what is FD? D to A. Okay, D to A is the FD. Here, D is the candidate key. Okay, here. So what about remaining things here? So BC, right? So B determines C. From this C here, B determines C will get, right? So B will be the candidate key. Okay. So now it is converted into what? Bicycad normal form.